Let's take a closer look at why transients are so dangerous. In this example, a service technician is making a phase-to-phase voltage measurement on a 480-volt motor supply circuit. This is a Cat 3 environment. A major voltage transient caused by load switching or a nearby lightning strike was large enough to cause an arc to strike inside the meter. Short-circuit currents as high as thousands of amps can flow for several microseconds. At these current levels, the tips of test leads superheat, and the handheld probe tips start to burn away, drawing an arc from the contact point to the probe tip. The tech sees a bright blue arc flash, and at the same time is startled by the bang of the arc exploding inside the meter. The arcs follow the vaporized test probes. If these two arcs join through close proximity of exposed metal from the test probes or other mechanisms, one large arc is formed, providing a low impedance path directly from one electrical phase to another. When two arcs join, they cause either a phase-to-phase or phase-to-earth fault. The result is an arc blast, which can lead to a plasma fireball fueled by the energy in the electrical system. When this occurs, temperatures can reach about 6,000 degrees Celsius or 10,000 degrees Fahrenheit. Industry sources estimate that in the U.S., 5 to 10 arc flash accidents occur each day. The U.S. Bureau of Labor reports that in one recent year, 1,000 electrical workers suffered shocks and burns, some fatal. It is estimated that 50% of these injuries are related to arc flash. This percentage could be dramatically reduced if technicians utilize the combination of careful planning, correct safe work practices, and use the right tools. Here is an actual arc flash. These fuses were designed to interrupt 10,000 amps of fault current, but are intentionally used on a 50,000 amp circuit. A dead short was created on the load side of the fuses.
My name is Ed Manthei. I've been a professional electrician for over 35 years in Eastern Washington, doing primarily commercial and industrial electrical work. About 2.5 years ago, I had a personal experience with arc flash. I heard a buzz, and then after that, a major explosion. I was able to get my eyes closed, I think, and my head back a little bit, blew me back on the floor. Next thing I remember, I was standing in the corner and I couldn't see, and my shirt and stuff was on fire, which I didn't even realize at the time, being as I couldn't see. And you know, me personally, I've always been accused of being too safe, overly cautious, because you can't. It's hard to prepare for something you can't see. Make sure that you use the proper safety precautions. I guess the bottom line is you can't be too careful.
Transients aren't the only source of arc flash hazard. In fact, one of the most common misuses of handheld multimeters can cause a similar chain of events. If the user leaves the leads in the amp's input terminals and then accidentally connects the meter leads across a voltage source, he has just created a short through the meter. That's why the amp's terminals must be protected by fuses. These fuses may be the only thing standing between that user and a potential disaster. If the meter is fused correctly, the only result may be a damaged fuse, which is a small price to pay. Never replace a damaged fuse with the wrong fuse. Only use high-energy fuses specified by the manufacturer. The Fluke meter system, which includes the meter's internal circuitry and fuses, and the test probes shipped with the instrument, works together to properly interrupt fault currents that exceed 10,000 amps. Test probes and other accessories can also contribute to danger. Test leads can become frayed or come out of the meter jacks. If the probe tip is connected to 480 volts and a nicked or underrated test lead comes in contact with another conductor, a fault may result. The same thing can happen if an unshrouded test lead comes out of the meter and touches a conductor. Make it part of your routine to inspect your meter and its test probes before using them. Please refer to the guidelines provided at the end of this video on what to look for. Remember, test probes are designed for a variety of test environments. What is appropriate for a circuit board in a Cat 1 environment may not be appropriate for 480 or 600 volt circuits. In a high energy setting, make sure your test probes have a minimum amount of exposed metal. This will help avoid creating a short between two phases if your hand slips off the probes.